Our next speaker and our last speaker before lunch is Brent Mecham. Brent is the Industry Development Director for the Irrigation Association, which is a trade organization for irrigation manufacturers, dealers, distributors, consultants, technical experts, and contractors with a mission to promote water-efficient irrigation. His career experience includes a Bachelor of Science degree in landscape horticulture, owning a landscape and irrigation contracting company, and creating an award-winning landscape water management program for a water conservancy district in Colorado. Brent has shared his passion for being a water steward by teaching and developing curriculum for both academia and industry. He believes in certification as a way to demonstrate competency and is IA certified as an irrigation water manager, designer, contractor, auditor, and agricultural irrigation specialist. So, Brent, please come aboard.
This is an opportunity that's really come about because of some of the things that have been going on in the marketplace with the introduction of green codes over the last several years, and recently the publication, for example, of IAPMO's green technical or green supplement for the plumbing and mechanical code. And all of these codes have some things in common, and a couple of them are, one, not to use potable water for irrigation, no problem with that. And then the other one is that maybe the idea of using smarter controllers to help make the irrigation events more efficient. And so that's really what I'm going to kind of talk about, is to say, what is this term, smart controller, which maybe sometimes is a catchy phrase and it's a good marketing thing, but it takes smart people to really make smart controllers effective. So one of the things we try to do is to use irrigation professionals who can really demonstrate that competency that it's going to take. The more precise we have to get, the higher the skill level will be, and it doesn't really matter whether it's a landscape system or the plumbing system, the mechanical system. All of these green codes are really raising the bar for expertise. The Irrigation Association has had a long-time collaborative effort with water providers that started in 2002. And it was really kind of one of these things, the water providers kind of saying, we have this big problem, and we need some cooperation from the irrigation industry, and that is to kind of ease the burden that's going on to the distribution systems within a utility. Most of the time that's driven by irrigation. And we need to figure out a way that people can still have the lovely landscapes but use less water to achieve that. And so that started in 2002. And some of the people that were at that meeting are here today. So somehow we're still surviving and we're finding progress. And so it's been a good cooperation between water providers and water users. And the outcome of that meeting was, well, let's create some testing protocols to find products that will really demonstrate that they will use less water. And so that testing protocol got started, and why we decided to take the most difficult one first, I don't know, but it was new products that were just being introduced into the marketplace, where instead of a controller being based just upon how many minutes I put on, which was always a guessing game, now it was trying to measure the environment that plants were growing in and determine how much water do they need in order to be healthy. And so it was a very big change in the type of equipment and the paradigm of thinking. And so we have that developed for controllers, whether they be weather-based or soil moisture-based. We have one that will be coming out for pressure regulating sprinklers, because there's an awful lot of water that can be conserved if we just have sprinklers operating at the correct pressure. And most of the time it's a lot lower than many people think. It's not necessarily more pressure is the better. Most sprinklers, spray heads, 30 psi is all that's needed. For the rotors, that in most residential properties, about 45 pounds pressure. So it's significantly less than many people are thinking. And then we're looking at advanced nozzles and rain sensors. So we're going to talk a little bit about the smart controllers. They are in the marketplace. They've been around and are starting to gain recognition. And The reason they work is they're trying to estimate or even measure how much water has been drawn out of the soil by the plants. Okay, and then the idea is, well, we only need to replenish how much was taken out. And because plants respond to weather, every day is a little bit different, so there's not a really consistent, you know, I suppose a few climates are always ideally perfect, but most of them respond to weather. And so if it's hotter, obviously they're using more, and if it's cooler, they're using less, and if it's raining, we probably don't need to be irrigating at all. And so we created this protocol to measure adequacy and the excess, and I'll go into that in just a second here. The EPA, through the WaterSense program, has taken that protocol and has modified it a little bit, because one of the things with the protocol that, as we came up, we didn't have a pass or fail. We were testing products and just saying this is how they performed, and then you as the user would kind of say that's adequate or not. So maybe a water provider would look at it and say those are acceptable levels, and if a controller can't do that, then it's not going to be acceptable in our marketplace. The EPA WaterSense program kind of sets some thresholds that says, well, the adequacy needs to be at least 80%. Okay, if the plants need at least 80% of the water in order for them to maintain health. And then the other is to say, but we don't want to be overwatering the plants, so we really don't want any excess. And so they set a threshold. And so that is currently in the marketplace. And I guess the good news is that I think it was either Thursday or Friday, IAPMO R&T Labs released this first, well, I guess we'll call it a press release, that the first weather-based controller has now been certified by them. Talking to Stephanie Tanner, it takes a few weeks to get through all the systems, so if you go to the EPA website and look today, you will not find it listed there. I know because I checked yesterday afternoon. But in 3 or 4 weeks it'll be available, and so now one has done it, and it's from a small company. It's not one of the bigger players. That's going to put tremendous pressure on everybody else to say, well, we want to be on that bandwagon too, because the WaterSense program is changing the marketplace, and this is a great opportunity. I'm going to tell you a little bit about the testing protocol. It's complicated. Nobody has a landscape like this, but it's 6 unique landscapes, and one controller has to be able to control the irrigation for all 6 unique landscapes and do it without any human intervention. And so that's what makes these controllers different, is that it's one controller is able to take all these different inputs and figure out what needs to happen. And that's very different than the old time-based controllers that we're used to, because it would probably take 5 controllers in order to do this virtual landscape. And now we have one controller that can do it. And so there's different plants, different soils, different slopes, different sprinklers. There's all these different parameters that represents a very complicated landscape, and yet one controller has to be able to do it. The thing that happens to people if they really get one of these is it's not going to work the same way they're always used to. And I've been a victim of that, saying, well, it's 5:30 in the afternoon, zone 1 ought to be on, and I go out there and zone 1 isn't on, but zone 3 is watering. Something's broken. Well, what was broken is my old habit. And so what the controller really is doing is saying zone 1 didn't need any water, so we're skipping it. But zone 3 needed it, and so it was irrigating. And so those will be some of the changes that will be happening. So it's a complicated test. It's a 30-day test. That's all that gets reported. But the truth is these controllers are running for quite a long time, because they have to get in a 30-day window a specific, or at least a certain amount of ET, or how much water the plant needs, and there has to be some rain events and a certain amount of rain events. And so that makes it very complicated. And I've seen some of the tests that have gone on for 5 months waiting for that 30-day window when all the weather parameters were satisfied. So that means the controller was working continuously correctly, because it's only the last 30 days that get reported. The results are posted on the SWAT website, which is Smart Water Application Technologies. So you can go there and see the results. There's 32 weather-based controllers listed there, and there's a report, there's a summary report, which is one page, very easy for and intuitive for a consumer to read and understand. And there's also a more technical report that goes through how each product did in all the various tests. There are 8 soil moisture sensors that have been tested. And ultimately, they still have that same thing. The adequacy, meaning there's been a sufficient water applied, because it's really easy to save water by not watering. But the idea is, no, we want to keep the plants healthy, so a sufficient amount of water and minimizing the excess. So EPA set the bar that said the adequacy has to be at least 80%, and the excess can be no more than 5%. So no more than 5, and that's a very little bit of water, but it's measured, and you know, if the irrigation controller was running too long, it would create runoff, and that, or deep percolation. Anyway, that would be excessive amount of water. So the EPA Water Sense Label program set the threshold at 80% adequate, 5% excess. Now, programming them, and this is where the skill set comes in. And many of you probably maybe have an irrigation system, you probably have a yard, you're taking care of it, but you don't have all the science that goes behind it. So very specifically, these controllers want to know, well, what kind of soil you have. As I teach around the country, most people have 2 kinds of soil. It's rocky hard or clay gumbo. Those are not any of the choices available on the controller. But you have to know whether it's is it a silty clay loam or is it a sandy clay loam? Because every kind of soil has unique properties. The plant type, I have grass. Yes, that's grass, but is it a warm season grass or is it a cool season grass? Unless you actually know that, most people don't. But typically, southern climates have warm season grasses. Northern climates have the cool season grasses. Right here in Virginia, we're mixed up and we don't know what we have. So some people have both, one or the other. And so they're all green, but they respond differently. And so you need to be able to do that. How deep are the roots? Okay, because it's really how deep those roots are growing is really, well, that's the reservoir of water that's available in the soil that they can draw from. If they got really deep roots, they may only need to be watered once a week, not every day. And so that there's, but if, on the other hand, somebody laid the sod on soil that was ready for concrete, the roots might only be 2 inches deep, and truly you would need to water every day. So it all kind of depends. The microclimates, so that's one of the more difficult scenarios in the urban landscape, is that you have parts of the landscape that are in the shade, some are in full sun, some of them against a building that's brick and glass, some of them are on the north side, and you hope that the irrigation system has been built so that it takes into account all those microclimates so you can water correctly. Slope, obviously the steeper the slope, gravity takes over, and so you get runoff. How do you keep the water on a slope? Well, you end up watering for 1 or 2 minutes and letting it rest and soak, run it again for 1 or 2 minutes. And it may take 6 or 7 applications to get the water to stay on site, not run down the gutter. And then ultimately, how fast is the water being put on by the sprinklers? The application rate. All right, and so many spray heads put it on at 1.5 to 2 inches an hour, very fast, like a very heavy rainstorm. Other kinds of sprinklers maybe put it on at 1/4 inch or 1/2 inch an hour. But all that has got to be taken into account, and that's what the programming is. And so these controllers have been very successful at managing these complicated landscapes, and that's the test that the labs are doing, the certified bodies are performing now. So how do they do in the real world? Because we know the potential is really there. And these are some of the things that we have discovered. Number one is the controllers really do work. And there's various levels of sophistication. I'll talk about it in a minute. What we really need is better, more skilled professionals that understand not only the irrigation system, but they now have to understand the horticulture. You're combining both things in order to really manage the water. So you need to have an understanding of plant materials as well as understanding, how to put in the sprinklers. So that's one of the real challenges, is finding the skill set. Will the water savings be there? Yes, there is water savings, but there's always a range. And so it can be as little as maybe 5%, could be as much as 30% or 40%. It really depends on how much people were overwatering before. But we also had experiences where the smart controllers actually watered more than previously. And you say, well, that's not very smart. And a lot has to do with, well, how were we calculating that savings? Because if people were already under irrigating, deficit irrigating, barely keeping the plants alive, this is the one difference. These new controllers are meant to water appropriately. They're not designed to purposely under irrigate. So if, and I'll give you a great example. The state of Texas, for a long time, has had some provisions there to deal with water issues where they encourage people to under irrigate, keep the plants alive, but it's really under irrigating. And if you put one of these smart controllers into that kind of a scenario, it may want to water more because of the parameters that are putting in there. So will there be water savings? No. Will the plants be happier? Probably. But does it meet the need of the utility? And that's some of the things and challenges that have to go into it. And that's where that adequacy is. Well, maybe we don't need to water 100%. Can we figure out a way to water a little bit less and still keep the plants well? So it is the product out of the landscape irrigation industry that's been studied the very most. There are numerous university studies going on right now. I can think about 7 or 8 off the top of my head where these controllers are being looked at carefully because of the huge potential they have, and all it is we need to understand, do they really work, and what do we need to know in order to program them to get the maximum results. And so these studies are University of Florida, North Carolina State, South Dakota, Utah, Colorado, California, Texas. They're studied a lot, and a lot of water utilities have programs looking at it. When it's all said and done, they have the potential of saving water. They will work, but they only will work as good as the inputs that went into programming them. And so it's a big step from where we were. Is it perfect? Not quite, but we're closer, and I guess that's the good news. So I'm going to give you a rundown of what there is because, you'll be working with these. Building officials are going to be called upon to inspect them because now the green codes are saying there will be a smart type controller put in. And so here's the general type, and these are kind of in the category of the least expensive, working my way up to the most expensive. The historical ET, and ET is that not the little guy that says phone home from 1980, but it's evapotranspiration. It's a term that just says how much water is being evaporated or used by the plant out of the ground. And a lot of them use historical information, and that's actually pretty good unless you get into a drought period of time where it'll be underestimating what the plant need is, but it's also at a time when you have less water to give, so maybe it works out okay. But they will take that historical curve or a month so that, July will always get more water than probably May or October. And then it takes real-time temperature sensors that says we are hotter or cooler than normal, and it'll make an adjustment to that historical ET curve. So those have been on the market for a while. They have been tested. They actually will work. And so it works out fine. They're the least expensive. The most popular right now seems to be the controllers that have on-site sensors, meaning they have a weather sensor of either temperature, some humidity, measuring how bright the sunshine is. And so all of these are looking at that specific site, measuring the weather parameters, and actually feeding that information into the controller, who's got a little guy inside that's taking all that information and doing the calculations. So it can figure out, okay, this is how long something is going to run. And so where that sensor gets put becomes very important. Okay, if it's supposed to be measuring solar radiation, having somebody put it under the eave of the house will defeat its purpose. Or you put it someplace that gets shaded by a tree for half the day. It will be underestimating, how much water. So where the sensors go becomes very important. And again, it takes a little bit of skill for somebody to recognize that. This is an example of a system being installed, and some of these are brand new controllers. Some of them have a module that will just plug into an existing controller if that's the same manufacturer. But this is an example where they got a very tiny sensor, but it's got temperature, and it's measuring the intensity of the sunlight, which is what really drives how fast plants grow. And just making sure that it gets put in, and then it gets plugged into the controller, and all the programming is taking place really in that little module off to the side. Okay, so it's being plugged into an existing controller, and this is proprietary, so Hunter has a product that fits in and retrofits to many of their controllers that they've made over the years. So that's kind of a cool thing, as a plug-in device to upgrade what you already have. Paging controllers are really, the good news is that they can get weather data from really good weather stations that are located all over the country, and you pick one that's very close to you, and that they can then download the signal from that weather station. Some of them will actually download all the weather data coming from the weather station, the wind speed, the temperature, the humidity, the brightness of the sun. Or others of them will measure all that and then just download the value that you need to put on a 1/4 inch of water for today. But this way it's being paged. Now, there's a fee in order to get that paging signal. So in some ways, it's kind of repurposing a lot of satellites, and they're using technology that we have all since forgotten. How many of you still have a pager? None of us. But those satellites are still wandering around in the sky. And so they're using that technology to communicate individually, site by site. And so a small monthly fee. It's, as I tell people, it's less than 1 Starbucks. You know, and you have an automatic updating every day of what's going on in your site, measured with a real good weather station nearby. This is the growing trend right now, is the internet and using that. And these are more sophisticated, but it allows me as the user to be controlling the irrigation in Colorado, because I can access the controller from my office here, there, and depending on what kind of sensors you put with it, you can actually get a report back. Did the irrigation system really run last night? Yes, it did. It would tell me how long for every station that I have programmed. You will find that these controllers tend to be for larger commercial sites. They're not necessarily for a residential that's got just a real small yard, although high-tech people love this kind of stuff, so they might have one. But it allows good active water management, and you can do it remotely. So there are companies that are utilizing this on all of the sites. Especially works good if you're a really large commercial company and you have 100 sites that you're trying to manage. And now you can do the management from a central office. And if there's problems, you can get a report. You can send your crews out there to look at it. And so they're doing it via the internet. Again, there'll be a small monthly fee, but as long as and you can get the internet almost anywhere, because now it's all wireless. You don't need a dedicated phone line or anything like that. And so these are very much being used in the commercial setting more than they are residential. I'm going to talk about the soil moisture, because that's the other way of looking at it. And these, I would like to say, are electronic roots. They're in the soil, right in the root system, and they are monitoring what's going on in the soil. And if the soil's too dry, sends a signal back to the controller and says, I'm thirsty, you ought to irrigate. And depending on how sophisticated you want it to be, it'll actually say, I'm wet enough, you can turn off now. And these sensors are not one for every zone, but you put them into what we would call hydrozones. So if you've got 10 zones that are all grass, you find a representative, and whatever that one does, all the ones like it will do the same thing. Then you might have a different sensor for the shrubbery, or a different sensor on the north side of the property. And so there are ways to be very sophisticated, and instead of having a weather station, you are now having a little soil moisture sensor who's making a decision. Again, it takes great skill to say, put it in the right spot. Don't put it in a low area where it might be too wet. Don't put it on a high spot that might dry out too fast. Don't put it too close to a sprinkler. And every one of these takes some skill as far as the installation, the wiring, etc. So I guess in quick summary, the smart controllers are designed to water plants appropriately. Will we save water? Based upon what we have historically done, that should save us 20 or 30% because most of us tend to overwater because we don't fully comprehend how much water the plants need. The good news is they can do it automatically. These products have been tested a lot by industry, by certifying bodies now, so the tests are posted. You can see what they are. It requires competent professionals to really get the best efficiency and to maximize that. And we tend to be an industry that uses a very low skilled labor. And so that's going to be a real problem, is to match up labor skill with the technology. And then all by itself, and this is maybe the disappointment, no matter how good the smart controller is, it cannot fix a bad performing sprinkling system. So it's part of a system, and you get best results if you just have a great system to start with. Guess I'm ready for questions.
Brent, Bill Hoff, an excellent presentation. One other thing you may want to comment on that I've seen with the smart controllers, particularly in large systems, is that once you get them in and the person can sit at the computer and monitor it, all of a sudden they know where to send the repair crews now to get them fixed. And
Correct.
it's significantly bigger savings than you just estimate out of the ET component that you get out of this.
Yeah, so for many of the people who are using it, the significant savings is not just the water and the water bill. And as we move on to alternate water sources, you know, you're not going to save money because of a decreased water bill, but you're going to improve the efficiency of your crews. You can start to do a better job or focus your attention on the things that always got ignored before.
Question here.
Doug McCluskey from the Construction Industry Skills Council Australia. Just from saving on potable water, I'm just interested to know, given that you represent the irrigation industry, what percentages of water are recycled or harvested in relation to via percentage to potable water used in these systems?
So there's probably actually another part to that. So most of our irrigation systems have been put on a potable water supply because it's readily available over the years. Harvested systems are actually kind of new and coming into our marketplace. It's being driven and it's appropriate because plants don't need potable water to thrive. Harvested systems, if it's 1% at this point in time, I'd be surprised. However, we do have a lot of systems that use, if you will, secondary water, meaning that it's raw water. So in Colorado, where I'm originally from, many of the larger irrigation systems, parks departments, school districts, golf courses, none of them were using potable water, but they were using the same kind of water that came out of the lakes or streams or rivers that might have been supplying the city. And so when you start to look at the fact that there's a number of systems that are already not on the potable supply, that might be another 20%. But they tend to be really large systems. When you get into the residential market, it's 99% are going to be potable supply. Even if they had their own well, they would be tapping off of that. So there's a huge opportunity there.
I was talking with the National Water Resource Association about smart farmers using smartphones for smart water use. How you talked about the internet-based systems, how much of these are going into mobile apps so people can not only use their crews better, but actually have their crews out in the field getting the information real time through an app? Okay, so there's, people more connected to technology than me have created apps already. So what I'm finding is that the next generation, who is all geared and wired to do this kind of stuff, is all over it. So yes, smartphones are being used to control irrigation all the time. It actually is a great advantage that if you're doing service work, you can walk around the property with your smartphone and be activating the irrigation system, and it cuts down on the labor and the time it takes to actually resolve the issue.
So that's growing all the time. One of the soil moisture sensor companies, that is the only way that you're working with their controller is through a smartphone. They don't even make an application for it to be on the on your desktop. So it's definitely a trend that's there.